for tuning into this video. So far in this chapter, we've been working a lot with inequalities. Tonight, this video is over solving compound inequalities, or it's an introduction to it. So first of all, what is a compound inequality? I want you to go ahead and highlight or underline this definition. So a compound inequality consists of two distinct inequalities joined by the word and or the word or. So the key thing for a compound inequality is that a compound inequality, it's two distinct inequalities. So think about like two bricks. It's like two bricks, but it's joined together by some cement in between there. With a compound inequality, you have two inequalities, and it's either joined by the word and or the word or. So let's first talk about the compound inequality that consists of the word and. So an example in words is all real numbers that are greater than -2 and less than 6. So here we have two inequalities. Okay, our first inequality is that all real numbers are greater than -2. So x is greater than -2 and less than 6. So one inequality is x is larger than -2, and my other inequality is x is less than 6. So those, in this compound inequality, these are my two distinct inequalities. Now, whenever a compound inequality consists of the word and, you can actually join these two inequalities and write them as one statement. So you know that x is larger than -2. So I can put -2 right here, and I could put x right here. So x is larger than -2, and it's also less than 6. So less than 6. Okay? So this is another way of writing this up here. Whenever you are writing a compound inequality and it's joined by the word and, I would prefer you write it like this. So x is greater than -2 and x is less than 6. Even though it's written as one statement, this is still two distinct inequalities. If I were to graph this, I would draw my number line. My -2 is right here, my 0 is here, and my 6 is here. X is larger than -2, open circle, and x is less than 6. So x is somewhere in between here. It's between -2 and 6. So a solution of compound inequality involving and is any number that makes both inequalities true. So so the solution x has to satisfy this inequality as well as this inequality. So the solution would be anywhere between -2 and 6. Let's go ahead and look at another one. Another example is, example 2 is all real numbers that are greater than 5 and less than 10. So let's write this out first. So x is going to be greater than 5, but it's also going to be less than 10. So those are my two distinct inequalities. The other two distinct inequalities, I can go ahead and write them as one statement. So my 5 on this side, x is larger than 5, but x is also less than 10. So my two inequalities can be written like this. Now remember, a solution to this inequality is any number that makes both this inequality true and this inequality true. So in order for it to be a solution, x has to be both larger than 5 and also less than 10. I think this is more obvious when we graph it. So here's my 0, here's my 5, here's my 10. X has to be larger than 5, so it has to be somewhere to the right of 5, but it also has to be less than 10, so it also has to be to the left of 10. So my solution is going to be any number that's between 5 and 10. Okay? Now let's go ahead and look at a compound inequality that consists of the word or. So these are actually a little different. So for this one, it is joined by the word or. We have all numbers that are less than -1 or greater than 5. So we can start writing this out the same way. So all real numbers that are less than -1, so x is going to be less than -1 or greater than 5. So I'm going to put or x is greater than 5. So again, for this compound inequality, even when it's joined by the word or, it is still two distinct inequalities. The difference between an inequality that consists of the word or and the one that consists of the word and is that the solution to a compound inequality involving or is any number that makes either inequality true. So with our compound inequality with the word and, both our inequalities had to be satisfied. Whereas when it's an inequality that has the word or, only one of these inequalities has to be satisfied. Okay? Let me graph it and then I think you'll see what I mean. So I have my -1 here, 0, 5. So x is less than -1. So I'm going to have an open circle. It's less than -1, so it's going to go this way. And x is greater than 5. So open circle, and it's going to the right. Notice that this is different than our graph right here. In this graph, with the word and, there's only one interval where the solution can be, only one segment of the number line. Whereas here, the solution can be either on this whole side of the number line, like everything to the left of -1, or the solution can be everything to the right of 5. So with the compound inequality with the word or, there's actually two sets of numbers that can satisfy the inequality. Go ahead and underline this sentence. A solution of a compound inequality involving or is any number that makes either inequality true. So the solution can be either the x is less than -1, any number to the left of -1, or a solution of this compound inequality can also be any number to the right of 5. So for this one, there's two sets of numbers that can satisfy the inequality. Whereas with the other inequality, there's only one section of numbers that would be able to satisfy it. Let's look at one more example. Let's get this straight away. Okay, our last example is all real numbers that are less than 16 or greater than 29. Let's write this out first. So all real numbers that are less than 16 or all numbers that are greater than 29. Okay, so those are my two inequalities. Okay, so my solution is, the solution can be either any number that's less than 16 or another possible solution is any number that's greater than 29. So again, for this inequality, when we graph it, we're going to have two sets of numbers that could satisfy this compound inequality. So let's have my 0 here, my 16 here, my 29 here. So x is less than 16, open circle, shade to the left. So my solution could be any number to the left of 16 on the number line, or my solution can be anything to the right of 29 on the number line. Either this set of numbers, everything to the left of this, or to the right of 29, any of those numbers would satisfy this compound inequality. Okay, go ahead, and I would like you to try the practice problems on your own. And then on Tuesday, we'll go over them. God bless you, and I hope you have a good weekend.